Good morning, student. Today again we discuss about the semiconductors part. Still remain back. ఇంకా ఉంది దాంట్లో ఇంకా అయిపోలేదు. That is today we'll discuss about the diodes characteristics, IV characteristics, their current and potential differences, and one more thing, what happens in the case of forward bias and reverse biased when the junction diodes are biased with a positive to negative or negative to terminals, interchanging their terminals, what happens, their characteristics, that all, let's have a look over it. And hope you remember the yesterday's class. నిన్న ఏం చెప్పుకున్నాం మనం? పీ టైప్ అండ్ ఎన్ టైప్ సెమీ కండక్టర్స్ కన్స్ట్రక్షన్ గురించి మాట్లాడుకున్నాం, రైట్? అండ్ పిఎన్ జంక్షన్ ఫార్మేషన్, స్పెషల్గా పిఎన్ జంక్షన్ ఫార్మేషన్, హౌ ఇట్ ఫార్మ్స్, isn't it? We had also concentration on that subject topic, and today we'll deeply discuss about junction diodes symbol and static IV characteristics, as well as zero biased PN junction diodes, uh, increasing depletion layer, what happens in reverse biased, zero biased and forward biased. Okay, right. Now I'll take out the screen, children. So a junction diode symbol and static IV characteristics you will study. Before we can use the PN junction as a practical device or as a rectifying device, we need to firstly bias the junction. That is, connect a voltage, a potential across on the voltage axis above, or a reverse bias refers to an external voltage potential which increase the potential barrier, and external voltage which decreases the potential barrier is said to act in a forward bias direction, right? This is the symbol, this blue color N type semiconductor, and P type semiconductor gray color, cathode K and anode a negative and positive terminal, conventional current flowing, right? And reverse voltage, ఈ ఫిగర్ చూడండి, మీరు ఫిగర్ చూడండి. రివర్స్ బ్రేక్ డౌన్ వోల్టేజ్ అండ్ ఫార్వర్డ్ బ్రేక్ డౌన్ వోల్టేజ్, జీనార్ బ్రేక్ డౌన్, అవలాంచి బ్రేక్ డౌన్. ఓకే, సో జర్మేనియం అండ్ సిలికాన్కి బ్రేక్ డౌన్ ఎంత ఉంది? దట్ ఈస్ 0.3 volts జర్మేనియం అండ్ 0.7 ఫర్ సిలికాన్స్. ఓకే, దట్ ఈస్ అ పొటెన్షియల్ డిఫరెన్స్ వెన్ దే ఆర్ అట్ జీరో బయాస్డ్. ఆ పరిస్థితిలో అలా ఉంటుందన్నమాట. సో జంక్షన్ డయోడ్ ఫార్మేషన్ అయినప్పుడు ఆ విధంగా ఉంటుంది. అందుకే ఏమంటారంటే, బట్ బిఫోర్ వీ క్యాన్ యూజ్ దిస్ పిఎన్ జంక్షన్ యాజ్ ఎ ప్రాక్టికల్ డివైస్ ఆర్ యాజ్ ఎ రెక్టిఫైయింగ్ device, we need to firstly bias the junction, that is connect a voltage potential across it on the voltage axis above the reverse bias, refers to an external voltage potential which increases the potential barrier, and external voltage and decreases the potential barrier is said to act as a forward bias direction. And right, a cathode, yeah, this is the figure. There are two operating regions and three possible biasing conditions for the standard junction diodes, and these are zero bias, no external voltage potential is applied to the PN junction diode, or reverse bias, the voltage uh, potential is connected, that is positive to the P terminal material, P type material, and negative to P type material, and positive to N type material across the diode, which has the effect of increasing the PN junction diode's width. Okay, and forward bias, the voltage potential is connected positive to P type material and negative to N type material across the diode, which has the effect of decreasing the PN junction diodes with zero biased junction diode. So when a diode is connected in a zero bias condition, no external potential energy is applied to PN junction. However, the diode's terminals are shorted together. A few holes, majority carriers and P-type materials with enough energy to overcome the potential barriers while moving across the junction against the barrier's potential. This is known as forward current and is referred as a IF. And likewise, holes generated in the N-type material, magnetic carriers, find this situation favorable and move across the junction in the opposite direction. So this is known as the reverse current and is referred as a IR. So this transfer of electrons and holes back from the back and forth across the PN junction is known as diffusion. Yeah, here you can see the diffusion. And zero biased junction diode. So the potential barrier that now exists discourage to diffuse of any more magnetic carriers across the junction. However, the potential barrier helps magnetic carriers to drift across the junction. So this is the figure you can note down and just a minute. Right. Okay. So N region and P region. Now you can see the potential built in for the N type and P type region junction is formed and there is no formula reverse bias. That means there is no potential what we call voltage is applied to this diode. Then the characteristics IV will be in this manner. Beneath you can see below that figure బిల్ట్ ఇన్ పొటెన్షియల్ లోపల ఎంత ఉంటుంది 0.3 నుంచి 0.7 వోల్టేజ్ వరకు మాత్రమే ఉంటుంది అన్నట్టు ఈ విధంగా రైట్ నౌ ఎస్ junction or the potential barrier helps magnetic carriers. Yeah, completed. Now I will go for the potential barrier that now exists discourages the diffusion of any more magnetic carriers across the junction. However, the potential barriers helps magnetic carriers. Potential barrier that now exists discourages the diffusion of any more magnetic carriers across the junction. The potential barrier helps magnetic carriers, few free electrons in P region and few holes in N region to drift across the junction. Then an equilibrium or balance will be established when the magnetic carriers are equal and both moving in opposite directions, so that the net result is zero current flowing in the circuit. When this occurs, the junction is said to be in a state of dynamic equilibrium. Balance will be established when the magnetic carriers are equal and both are moving in opposite direction, so that the net result is zero current flowing in circuit. When this occurs, the junction is said to be in a state of dynamic equilibrium. The magnetic carriers are constantly generated due to thermal energy. So this state of equilibrium can be broken by raising the temperature of the PN junction, causing an increase in the generation of magnetic carriers. So thereby resulting in an increase in leakage current, but an electric current cannot flow since no circuit has been connected to PN junction. It is generated due to the thermal energy. So this state of equilibrium can be broken by raising the temperature of PN junction, causing an increase in generation of magnetic carriers. So thereby resulting in an increase in leakage current, but an electric current cannot flow since no circuit has been connected to PN junction. Reverse biased PN junction diode. When a diode is connected in a reverse bias condition, a positive voltage is applied to N-type material and the negative voltage is applied to P-type material. The positive voltage applied to N-type materials attracts electrons towards a positive electrode and away from the junction, while the holes in the P-type ends are also attracted away from the junction. Okay? Now, the net result is that the depletion layer grows wider due to a lack of electrons and holes and present high impedance path, almost an insulator. The result is that a high potential barrier is created, thus preventing current from flowing through the semiconductor material. Increase in depletion layer due to reverse bias. That the depletion layer grows wider due to lack of electrons and holes and present a high impedance path, almost an insulator. The result is that a high potential barrier is created, thus preventing current from flowing through the semiconductor material. Increase in depletion layer due to reverse bias. Due to reverse bias. N region, P region. Width of depletion layer, right? So negative, positive, see this figure. If you compare this zero bias and reverse bias, zero bias ni reverse bias ni compare చేసి చూడండి ఒకసారి ఏమవుతుంది, right? So this is a reverse bias. ఏం లేదు, just yellow color portion is చూడండి. That portion will be get widened. ఈ విధంగా వైడెన్ అయింది ఇక్కడికి దీనికి కంపేర్ చేస్తే. Okay, now and the figure is like this. It shows increase in depletion layer due to reverse bias. On a final point, if the reverse bias is a voltage VR applied to the diode is increased to a sufficiently high enough value, it will cause the diode's PN junction to overheat and fail due to avalanche effect around the junction. This may cause the diode to become shorted and will result in the flow of maximum circuit current, and this shown as a step downwards slope in the reverse static characteristics curve below. So the reverse characteristics curve for junction diode, sometimes this avalanche effect has practical చూడండి రివర్స్ బ్రేక్ డౌన్ రీజియన్ చూడండి, ఇక్కడ నుంచి బ్రేక్ డౌన్ తీసుకుంది రివర్స్ బయాస్ జంక్షన్లో. sometimes this avalanche effect sometimes this avalanche effect has a practical uh, what we call applications in voltage stabilizing circuits, whereas a series limiting resistors is used with the diode to limit this reverse breakdown current to a present maximum value, thereby producing a fixed voltage output across the diode. So these types of diodes are commonly known as Zener diodes, are discussed in a later tutorial. Forward bias PN junction. Coming to the forward bias PN junction diode, when a diode is connected in a forward bias condition, a negative voltage is applied to N type material and positive voltage is applied to P type material. If this external voltage becomes greater than the value of potential barrier, approximately 0.7 volts for silicon, 3 volts for germanium, the potential barrier opposition will be overcoming and current will start flowing. So this is because the negative voltage pushes or repels electrons towards the junction, giving them the energy to cross over and combine with the holes being pushed in the positive direction towards the junction by positive voltage. So this result in characteristics curve of zero current flowing up to this voltage point called the knee or the static curves, and then high current flows through the diode with a little increase in internal external voltage as shown below. And forward characteristics curve for junction diodes. The application of forward biasing voltage on a junction diode results in the depletion layer becoming very thin and narrow, which represents a low impedance path through the junction, thereby allowing him high currents to flow. So the point at which the sudden increase in current takes place is represented on the static IV characteristics curve above as the knee point. So the point at which the sudden increase in current takes place is represented on the static IV characteristics curve above as the knee point. Okay. Right. So this is the graph you can see here. Graph student, silicon diodes, exactly opposite to the earlier case. This reverse bias law, yeah. This is the reverse bias. This is the reverse bias case. Avalanche effect has a practical itla ee vidhanga untadi reverse bias. Okay, and now uh, ఫార్వర్డ్ బయాస్లో ఈ విధంగా ఉంటుంది. ఫిగర్ ఇవ్వలేనట్టుంది ఫార్వర్డ్ బయాస్లో. దిస్ ఈజ్ ఫర్ పిఎన్ జంక్షన్స్ రివర్స్ బయాస్. సిమిలర్లీ ఫార్వర్డ్ బయాస్ figure has not given children. I will try in the next. So this is all about the PN junction diodes forward and reverse conditions, right? Now we will go for another topic, children, that is wait just a minute. So yeah, half wave and full wave rectifiers. Now after junction diode we will go for rectifiers, half wave and full wave rectifiers. Half wave rectifiers working principle and characteristics. A rectifier is an electronic device that converts AC voltage into DC voltage. In other words, it converts alternating current to, direct current. A rectifier is used in almost all electronic devices. Mostly, it is used to convert the main voltage in DC voltage in power supply. By using DC voltage supply, electronic devices works according to the period of conduction. Rectifiers are also classified into two categories: half wave rectifier and full wave rectifier. Okay, what is half wave rectifier? You will see. During the positive half cycle, the diode is under forward biased condition and it conducts current to RL, load resistance. A voltage is developed across the load which is the same as the input AC signal of positive half cycle. Here you see this. This is the input waveform of half wave rectifier, and V maximum diodes and load resistance or rectified out wavefront waveform. Chudandi how it has become. There is no negative half cycle in this. Only positive half cycles can be seen. Negative half cycle లేదు దీంట్లో, అవునా కదా? So this is the figure for half wave rectifiers. Half wave rectifier signals. Now, yeah. Alternatively, during the negative half cycle, the diode is under a reverse bias condition and there is no current flow through the diode. Only the AC input voltage across the load, and it is a net result which is possible during the positive half cycle. The output voltage pulsates the DC voltage. Rectifier circuits, single phase circuits or multi-phase circuits comes under the rectifier circuits. So more domestic applications, single phase low power rectifiers circuits are used, and industrial HVDC applications require three phase rectifications. The most important application of PN junction diode is rectification, and it is the process of converting AC to DC. In a single phase half wave rectifier, children, either negative or positive half of the AC voltage flows while the other half of the AC voltage is blocked. Hence, the output receives only one half of the AC waves. Right? So, a single diode is required for a single phase half wave rectifiers and 3 diodes for 3 phase supply. So half wave rectifier produce more amount of ripple content than the full wave rectifiers, and to eliminate the harmonics it requires much more filtering. Right? Now this is the transformer here. Vs, inputs, diodes, voltage. This is a circuit, very important circuit. Rectifier output voltage of a current waveform ఈ విధంగా ఉంటుంది, isn't it? Now, right, this is the small figure same the similar figure, similar structure or original structure. uh, this is the original structure, right? Now, for a sinusoidal input voltage, the no load output DC voltage for an ideal half wave rectifier is Vrms, V peak by 2, VDC, V peak by N, where VDC and VAC minus DC output voltage are average output voltage. V peak minus peak value of input phase voltage Vrms. So the output voltage of uh, root mean square value. Root means square values. Okay. Now operation. Operation of half wave rectifier. A PN junction diode conducts only during the forward bias condition. Half wave rectifier use the same principle as a uh, yeah. This half wave rectifier use as a same principle. So PN junction diode conducts only due to forward bias condition. Half wave rectifier uses the same principle as a PN junction diode and thus converts AC to DC in half wave rectifier circuits. The load resistance is connected in a series with the PN junction diodes. So alternating current is the input of half wave rectifier. Step down transformer takes an input voltage and results uh, output transformer as a given to load resistors and to the diodes. So during the positive half cycle, the diode is under forward bias condition during the negative half cycle and the diode is under reverse bias condition. The voltage output is measured across the load resistance. So during the positive half cycle the output is positive and significant, and during the negative half cycle the output is zero or insignificant. This is known as half wave rectification. Now working of half wave rectifier. So during the positive half cycle, when the secondary winding of the upper end is positive with respect to the lower end and the diode is under forwarding bias condition and it conducts current during the positive half cycle, the input voltage is applied directly to the load resistance when the forward resistance of the diode is assumed to be 0. So the waveforms of output voltage and the output current are the same as that of AC input voltage. So during the negative half cycle, when the secondary winding of the lower end is positive uh, with respect to the upper end, the diode is under reverse biased condition and it does not conduct current. So during the negative half cycle, the voltage and the current across the load remains 0. The magnitude of the reverse current is very small and it is neglected. So no power is delivered during the negative half cycle. A series of positive half cycle is output voltage that is developed across the load resistance. The output is pulsating DC and makes the smooth output wave filter which should be across the load as used as input wave of half cycle, and then it is known as half wave rectifier. Now advantages of half-wave rectifier. Okay, advantages of yeah. So this is the figure, children, for this half-wave rectifier. Okay, children, this is the figure for half-wave rectifier. Diodes, only one diode is there on the upper circuit. Primary coils is connected there. Half-wave rectifier, right? So operation of half-wave rectifier. A PN junction diode conducts only during the forward bias condition. Half-wave rectifier uses some principle as a PN junction diode and thus converts AC to DC in a half-wave rectifier circuit. The load resistance is connected in a series with the PN junction diode, alternating currents in the input of the half-wave rectifier. A step-down transformer takes an input voltage and the resulting output of the transformer is given to the load and the diode. So during the positive half cycle, the diode is under the forward bias condition. During the negative half cycle, the diode is under reverse bias condition. The voltage output is measured across the load resistance during the positive half cycle. The output is positive and significant, and during the negative half cycle the output is zero and insignificant. This is known as the half wave rectifier. Working process, how it works, children, let us see. So during the positive half cycle, when the secondary winding of upper end is positive with respect to the lower end, the diode is under forward bias condition and it conducts current during the positive half cycle. The input voltage is applied directly to the load resistance when the forward resistance of the diode is assumed to be zero. The waveforms of output voltage and the output current are the same as that of the AC input voltage. So during the negative half cycle, when the secondary winding of the lower end is positive with the respect to the upper end, the diode is under reverse bias condition and it does not conduct current. During the negative half cycle, the voltage and the current across the load remains zero. The magnitude of the reverse current is very small and it is neglected. So no power is delivered during the negative half cycle. A series of positive half cycle is that output voltage that is developed across the load resistance. The output is a pulsating DC wave, and to make the smooth output wave filters which should be across the load are used. If the input wave is on half cycle, then it is called half wave rectifier. ఇది అసలు జరిగే కథ. Now you must know that what we call applications. Vrms is equal to V peak by 2 and Vdc is equal to V peak by n. Right? A schematic diagram for half wave rectifiers. Now, advantages of half wave rectifier, if we take. What are the advantages? Half wave rectifiers are very cheap, children, cheap, and they are simple. They are easy to use. Half wave rectifiers are chala simple and they are very easy to use. That half wave rectifiers use chala easy అంటారు. At low number of components. Low number of components చాలా low ఉంటాయి. Okay, low number of components, that is they are cheap, simple, easy to use, low number of components. And disadvantages: half wave rectifiers more amount of ripple content ఎక్కువ ఉంటుంది. And transformer utilization factor is very low, rectification efficiency is low, and generates harmonics. These are the disadvantages. More amount of ripple content, transformer utilization factor is very low, rectification efficiency is low, generates harmonics. Okay, more amount of ripple content, transformer utilization factor is very low, rectification efficiency is low, generates harmonics. They generates harmonics. Generates harmonics. To use low number of components. So yeah, so this is all about half wave rectifier. And that too, today we studied both PN junctions forward bias and reverse bias. So based on this forward bias, reverse bias only, this can be studied. Chudandi, that's why I said when it is forward biased, only the pulsating positive signals are there from 0 to x, and x2 to x there is no flow of current. Okay, negative current is there, and again from 2x to 3x, again the positive potential difference or current is there, DC IDC is there, direct current is flowing, and potential difference is not there here. Okay, that's why from 3x to 4x 0, 3x to 4x, right? And rectifier output voltage or current waveform, rectifier's output voltage or current waveforms, 3 diodes for 3 phase apply. Half wave rectifier produces more amount of ripple content, terminate the harmonic, it requires much more filterings. Negative of cycle, diode is under reverse bias condition and there is no current flow through the diode, only the AC input voltage appears across the load, and it is the net result which is possible during the positive half cycle. So that's why in positive half cycle only we can see actually the input signal is both we maximize potential difference minimum, both as given as a input. Rectifier input voltage ఈ విధంగా ఉంటే rectifier positive voltage అవుట్పుట్ వోల్టేజ్ మాత్రం లైక్ దిస్, ఇన్పుట్ వోల్టేజ్కి కరెక్ట్ అవుట్పుట్ వోల్టేజ్ ఈ విధంగా ఉంది, రైట్? సో చిల్డ్రన్, దిస్ ఈజ్ ఆల్ అబౌట్ ఇన్ ద నెక్స్ట్ క్లాస్ we will come forward with another topic. Till then, see you, bye. I will